Good morning, everyone. Today we have to start one more topic, seventh topic, that is wave optics. Wave optics. Today we have to start one more topic about wave optics, seventh topic. Now see. First, we have to see Huygens wave theory of light. Huygens wave theory of light. Huygens wave theory of light. Let's see. This theory was proposed by Huygens in 1668. This theory was first proposed by Huygens in 1668 on the basis of some following assumptions. First, that is nature. According to this theory, suppose this one as source of light, then light is in the form of waves. According to this theory, light is in the form of wave, travels along a straight line with uniform velocity in uniform medium. According to this theory, light is in the form of waves caused due to vibrations of particles of medium. Vibrations of particles of medium. Light is in the form of waves caused due to vibrations of particles of medium emitted from source of light and travels along a straight line with uniform velocity in uniform medium. First assumption about nature. According to Huygens theory, light is in the form of waves emitted from source of light. Light is in the form of waves emitted from source of light due to vibrations of particles of medium, travels along a straight line with uniform velocity in uniform medium. Second, that is about colors. According to this theory, different colors of light are due to different wavelengths of waves. Wavelengths of waves. म्हणजेच वेवलेंथ चेंज झाली तर त्याचा कलर पण चेंज होत असतो. According to this theory, different colors of light are due to different wavelengths of waves. Third, about ether. For the propagation of light waves, some hypothetical medium is required, which is continuous. Hypothetical medium is required, which is continuous, present everywhere, and has zero density. According to this theory, for the propagation of light waves, some hypothetical medium is required, which is continuous, present everywhere, and has zero density. Fourth, about velocity. According to Huygens wave theory, velocity of light in rarer medium is greater than velocity of light in denser medium. One more point, fifth point, that is different phenomena such as reflection of light, refraction of light, inverse square law, interference, diffraction can be successfully explained on the basis of this theory. These are 5 points. See, Huygens wave theory of light. This theory was put forward by Huygens in 1668 on the basis of some assumptions. First, about nature. According to this theory, light is in the form of waves, caused due to vibrations of particles of medium emitted from source of light and travels along a straight line with uniform velocity in uniform medium. Second, colors. Different colors of light are due to different wavelengths of waves. Ether. For the propagation of light waves, some hypothetical medium is required, which is continuous, present everywhere, and has zero density. Fourth one, about velocity. Velocity of light in rarer medium is greater than velocity of light in denser medium. And some phenomena such as reflection of light, refraction of light, inverse square law, interference, diffraction can be successfully explained on the basis of this theory. This is about Huygens wave theory of light. Now, about wavefront of wave. Wavefront. About wavefront of wave. See, consider a point source S situated in homogeneous and isotropic medium. Consider a point source S situated in homogeneous and isotropic medium. Then this source emits waves in all possible directions. This source emits waves in all possible directions like this. If suppose C be the velocity of wave, if V be the velocity of wave, then in time t, distance covered by wave is equal to V into t. Velocity into time. Distance is nothing but velocity into time. If V be the velocity of wave, then in time t, distance covered by each wave is equal to Vt. Suppose this distance is Vt. Then in same time, each wave will cover equal distance and reach on the surface of sphere with source of light is center and radius is equal to Vt. हा जो स्पियर आहे, ह्या स्पियरचा सेंटर आहे S, सोर्स ऑफ लाईट, आणि त्याची रेडियस R. मीन्स all these points forms at a time. As all these points produces at same time, all these points are in same phase. See once more. Consider a point source of light S situated in homogeneous and isotropic medium, then this source emits waves in all possible directions. If V be the velocity of wave, then in time t, distance covered by wave, each wave is equal to Vt. At reach of the surface of sphere of radius Vt with source as the center, these points on the surface are in phase. Such a surface is called as wavefront. हे जे सर्व पॉइंट्स आहेत ह्यांना म्हणतात, ह्या सर्वांचा जो एकत्रित इफेक्ट आहे त्याला म्हणतात वेव्हफ्रंट. व्हॉट इज वेव्हफ्रंट? डेफिनेशन: the locus of all points of medium. लोकस म्हणजेच या सर्वांचा एकत्रित इफेक्ट. the locus of all points of medium. the locus of all points of medium to which each wave reach simultaneously. To which each wave reach simultaneously, so that all points are in same phase. Such a locus of point is called as wavefront. What is wavefront? Definition: the locus of all points of medium. The locus of all points of medium to which each wave is simultaneously, so that all points are in same phase, is called as wavefront. म्हणजे हे सर्वच्या सर्व पॉइंट्स एकाच वेळी तयार होतात आणि या सर्वांचा एकत्रित इफेक्ट म्हणून हा जो सरफेस तयार होतो, या सरफेसला म्हणतात थोडक्यामध्ये वेव्हफ्रंट ऑफ वेव्ह. व्हॉट इज वेव्हफ्रंट ऑफ वेव्ह? डेफिनेशन: the locus of all points of medium to which each wave is simultaneously, so that all points are in same phase, is called as wavefront. Now, types of wavefronts. Types of wavefronts. Types of wavefronts: spherical wavefront, spherical wavefront, cylindrical wavefront, and plane wavefront. A point source situated in homogeneous and isotropic medium produces a wavefront is called as spherical wavefront. इथं आपण काय म्हणतोय? पॉइंट सोर्स. A point source situated in homogeneous and isotropic medium produces a wavefront called as spherical wavefront. An extended source, समजा सोर्स या पद्धतीने असेल, an extended source of light, an extended source of light situated in homogeneous and isotropic medium produces a wavefront. This wavefront is called as cylindrical wavefront. Here point source, here an extended source, and third one, if source of light is at infinite distance, then समजा हा पॉइंट सोर्स आहे, याचा हा स्पेरिकल वेव्हफ्रंट. या स्पेरिकल वेव्हफ्रंटचा हा स्मॉल पार्ट acts as a plane. If source of light is at infinite distance, then small part of its spherical wavefront. म्हणजे समजा सोर्स ऑफ लाईट हा इन्फायनाइट डिस्टन्स वरती असेल तर त्याचा हा जो स्पेरिकल वेव्हफ्रंट आहे त्यावरचा हा स्मॉल पार्ट acts as a plane called as plane wavefront. Types of wavefronts: spherical wavefront, cylindrical wavefront, plane wavefront. What is spherical wavefront? What is spherical wavefront? What is spherical wavefront? A point source situated in homogeneous and isotropic medium produces a wavefront is called as spherical wavefront. An extended source of light situated in homogeneous and isotropic medium produces a wavefront called as cylindrical wavefront. And one more, if source of light is at infinite distance, then small part of its spherical wavefront acts as a plane. Such a wavefront is called as plane wavefront. Okay. Now, Huygens principle. Huygens principle. Huygens principle. Suppose this one as wavefront. Suppose this one as wavefront. Then every point on wavefront acts as secondary source of light. Every point on wavefront acts as a secondary source of light. समजा या ठिकाणी इथे एखादा सोर्स ऑफ लाईट आहे, याचा या ठिकाणी हा समजा एखादा वेव्हफ्रंट आहे. हा झाला आपला प्रायमरी वेव्हफ्रंट, याला म्हणतात प्रायमरी वेव्हफ्रंट, सुरुवातीचा वेव्हफ्रंट. देन every point on this wavefront acts as a secondary source of light, sending out secondary waves in all possible directions like this. First point, every point on wavefront acts as secondary source of light, sending out secondary waves in all possible directions, called as wavelets. These wavelets travels with a speed of light in medium. Second, the envelope of all these secondary wavelets. समजा हा एक वेवलेट आहे, हा एक वेवलेट आहे, हा एक वेवलेट आहे, मग हा वेवलेट, हा वेवलेट, हा वेवलेट, या सर्वांचा एनवलप म्हणजेच एकत्रित इफेक्ट. एनवलप that is resultant effect. The envelope of all these secondary wavelets in forward direction gives new wavefront at that instant. These wavelets travels only in forward direction, and therefore wavefront moving in backward direction does not exist. Third point like this. This is about Huygens principle. See, हे तीनही पॉइंट आपल्याला लिहायचे त्या ठिकाणी Huygens प्रिन्सिपल मध्ये. फर्स्ट, every point on wavefront acts as secondary source of light, sending out secondary waves in all possible directions, called as wavelets. These wavelets travels with velocity of light in medium. Second, the envelope of all these secondary wavelets, in forward direction at any instant gives new wavefront at that instant. The wavelets traveling in backward direction does not effective. This is about Huygens principle. आतापर्यंत आपण काय काय पाहिल्या ठिकाणी Huygens wave theory of light, wavefront, then types of wavefronts, spherical wavefront, cylindrical wavefront, plane wavefront, then Huygens principle. Statements 3 points आहेत. First point, every point on wavefront acts as a secondary source of light, sending out secondary waves in all possible directions called as wavelets. These wavelets travels with velocity of light in medium. Second point, the envelope of all these secondary wavelets, at any instant gives new wavefront at that point. As wavelets travels only in forward direction, the wavelet moving in backward direction are not possible. Now, one more point. Next point about reflection of light at plane surface. Reflection of light at plane surface. Reflection of light at plane surface. See, consider a plane reflecting surface. Consider a plane reflecting surface such as plane mirror. Consider a plane reflecting surface. Consider a plane reflecting surface M(n), such as plane mirror. Suppose that a plane wavefront. Suppose that a plane wavefront AB. Suppose a plane wavefront AB bounded by two rays that are RA and QB. Suppose that a plane wavefront AB bounded by two rays RA and QB obliquely incident on surface. This wavefront first reach at A and then successively from A to C. As soon as this wavefront reach at A, point A becomes secondary source of light and sending out secondary waves in same medium. Suppose this one as normal, this one as angle of incidence I. As soon as this wavefront reach at A, point A becomes secondary source of light and sending out secondary waves in same medium like this. Let incident ray QB moves from B to C in time t with velocity phi. Let phi be the velocity of wave and t be the time required to cover distance BC. Then distance BC is equal to velocity into time phi into t. Means time means distance covered by incident ray QB from B to C. This distance is equal to velocity into time. Velocity of wave phi time t means this distance BC is equal to phi into t. In same time, secondary wave from A will cover equal distance. जेवढं distance BC आहे तेवढंच distance इथं कव्हर होतं and reach at point D. At same time, distance covered by secondary wave from A equal distance and reach at point D, and therefore point C and T produces at same time T, and therefore CD acts as reflected wavefront. AB incident wavefront, CD reflected wavefront. This one as angle of reflection R. See once more. Let Mn be the plane reflecting surface such as mirror. Let Mn be the plane reflecting surface such as mirror. Suppose that a plane wavefront AB bounded by two rays RA and QB obliquely incident on surface. This wavefront initially reach at A. This wavefront first reach at A and then successively from A to C. As soon as this wavefront reach at A, point A becomes secondary source of light, produces secondary waves in same direction. If phi be the velocity of wave, and t be the time required to cover distance BC. If c be the velocity of wave and t be the time required to cover distance BC, then distance BC is equal to velocity into time. In same time t, distance covered by secondary wave from A to D. In same time t, distance covered by secondary wave is also equal to phi t and reach at point D, and therefore points C and T are in phase. सेम. म्हणजेच हा वेव्ह हिथून हिथं जाण्यासाठी जेवढा टाइम लागतो त्याच टाइम मध्ये हा सेकंडरी वेव्ह ए पासून डी पर्यंत जातो. याचा अर्थ सी आणि डी एकाच वेळी तयार होतात. देअरफॉर सी डी रिप्रेझेंट रिफ्लेक्टेड वेव्ह फ्रंट. AB that is incident wave front and CD that is reflected wave front. Okay, see once more. Let MN be the plane reflecting surface such as mirror situated in homogeneous medium. Suppose that a plane wavefront AB obliquely incident on surface at A, bounded by two rays RA and QB. This wavefront first reach at A and then successively from A to C. As soon as this wavefront reach at A, point A becomes secondary source of light and sending out secondary waves in same medium. If phi be the velocity of wave in this medium and t be the time required to cover distance bc, then distance bc is equal to velocity into time, that is phi t. In same time t, त्याच टाइम मध्ये distance covered by secondary wave is equal to phi t and reach at point t, and therefore points C and D are in phase and CD acts as reflected wavefront. Let PA be the normal on surface at A. Let PA be the normal to the surface at A. Then measure angle RAP. RAP is equal to angle of incidence I, which is equal to measure angle BAC, which is equal to measure angle BAC by geometry, called as angle of incidence. Angle RAP is equal to angle BAC, that is angle of incidence. Measure angle PAD. Measure angle PAD is equal to angle of reflection, which is equal to measure angle ACT by geometry. Means angle RAP is equal to angle BAC and angle PAD is equal to angle ACT by geometry. Now in triangle APC and triangle DAC or ADC, in triangle APC and triangle ADC, angle APC congruent angle ADC, both 90 degree. AC congruent AC, that is common. AC common है. Also BC congruent AD, BC congruent AD, both equal to phi t, and therefore triangle APC congruent triangle ABC congruent triangle B ला D, इथं AC ला AC, त्यानंतर BC ला AD, BC ला AD म्हणजे राहिले इथं शिल्लक C. बाय जॉमेट्री ट्रायंगल ABC congruent triangle CTA and therefore major angle A congruent major angle C, and therefore major angle BAC congruent major angle ACD, and therefore I is equal to R. Thus angle of incidence is equal to angle of reflection. Second, incident ray, reflected ray and normal lies in one and same plane, as AB is equal to CD, as AB is equal to CD, size of image is equal to size of object and is inverted. AB is equal to CD, and therefore size of image is equal to size of object but is inverted. In this way, reflection of plane wavefront can be explained on the basis of Huygens theory. Okay, next part on next period.